there is a joint that gets stronger every time the earth shakes. No nails, no screws, no bolts, no glue. Just wood meeting wood, with such precision that earthquakes make it tighter. For 1400 years, Japanese carpenters built temples that still stand today using nothing but this. Then we replaced it with nails. Not because nails are stronger. A single nail has 100 pounds of holding power. This joint has 5,000. We stopped because a nail takes 30 seconds, and this joint takes 4 hours. We chose speed over centuries. A joint that outlasts every building around it cannot generate repeat business, and a skill that takes 10 years to learn cannot be staffed from a temp agency. So the industry buried it. Not because it failed, because it made failure impossible. This is the story of the joint that has survived every earthquake for 14 centuries and still holds while the nailed world crumbles around it. Welcome to Lost Build Archives. Before we open this archive, if these forgotten techniques matter to you, the best way to preserve this knowledge is simple. Subscribe, hit the bell, and share these archives with those who need to remember what we forgot. The archive opens in the forests of Nara, Japan, in the year 607. Prince Shotoku has commissioned a temple, not just any temple, a monument to faith that he intends to stand forever. The carpenters he summons are not ordinary builders. They are miyadaiku, temple carpenters, men whose families have worked wood for generations. They select their timber with a precision that borders on ritual. Hinoki, Japanese cypress, for the columns that must bear compression. Sugi, cedar, for the beams that must flex without breaking. Each tree is chosen not just for its species, but for where it grew on the mountain. A tree that grew on the north face, leaning into wind its entire life, carries stress patterns in its grain that make it stronger under lateral load. The miyadaiku know this. They have always known this. They do not bring nails. They do not bring iron brackets or metal straps. They bring chisels, saws, and planes, and a knowledge system that contains over 300 distinct joint types. Each joint is designed for a specific purpose. Tsugite joints splice two timbers end to end, extending them into lengths no single tree could provide. Shiguchi joints connect timbers at angles, locking them into frames that distribute weight across the entire structure. The craft is called kigumi, the art of interlocking wood, and it requires a minimum of 10 years of apprenticeship before a carpenter is trusted to cut a structural joint alone. The temple they build is Horyuji. When it is finished, it's the most sophisticated wooden structure on Earth. 5 stories rise from a stone foundation, each story slightly smaller than the one below, tapering toward the sky. The central pillar, a single massive trunk of hinoki, hangs suspended from the top of the pagoda. It does not touch the ground. It swings like a pendulum. When the earth shakes, the pillar sways, absorbing energy that would shatter a rigid structure. The joints flex, redistribute load, and settle back into place. The building dances with the earthquake rather than fighting it. Horyuji is still standing. 1400 years. It has survived earthquakes that leveled cities, typhoons that stripped mountains bare, wars that burned everything around it. The oldest surviving wooden building on the planet, held together by nothing but the geometry of wood. But Horyuji was not unique. Across Japan, this knowledge built an entire civilization. Tadaiji in Nara, the largest wooden building in the world. Himeji Castle, a fortress of timber and plaster that survived World War II bombings and every earthquake since the 16th century. Kiyomizu-dera in Kyoto, whose massive wooden stage cantilevers out over a hillside without a single nail. Hundreds of structures, some of them 5, 6, 800 years old, standing in a country that experiences more earthquakes than almost anywhere else on Earth. The joints held. They always held. The secret was not strength, it was flexibility. A nailed connection is rigid. When an earthquake sends a shockwave through a building, a nail transfers that force directly from one timber to the next. The energy has nowhere to go. It accumulates until something breaks. A beam splits, a wall racks, a nail shears, and the connection fails catastrophically. A Japanese joint works differently. The interlocking geometry allows a tiny amount of movement between the timbers, not sloppiness, precision. The joint is carved so that under normal load it is tight and immovable, but under extreme lateral force, the earthquake, the typhoon, the timbers shift against each other by fractions of a millimeter. That movement absorbs energy. It dissipates the shockwave across thousands of joints rather than concentrating it at a single point of failure, and then the joint returns to its original position. The building flexes and rebounds. The Japanese builders had a phrase for this. Buildings should dance with earthquakes, not fight them, and many of these joints are self-tightening. The kawaitsugite, a cross-lap joint used in beam connections, is carved so that the weight of the structure above presses the two timbers more firmly together. The heavier the load, the tighter the grip. A nailed joint loosens over time as the wood shrinks and the nail corrodes. A kawaitsugite gets stronger over time as the wood compresses and the fibers mesh. After 100 years, you cannot separate the timbers without destroying them. They have become one piece. The numbers are devastating. A standard 16-penny nail driven into softwood provides roughly 100 to 120 pounds of pull-out resistance. A properly made okage daisentsuki, the oblique scarf joint used in temple construction, provides 2,000 to 5,000 pounds of shear resistance depending on the timber species and grain orientation. That is not a small improvement. That is an order of magnitude. A modern American home contains 20,000 or more nails. Every single nail is a point where water can enter the wood, where rust can form, where fibers are split and weakened by the act of driving the fastener. 20,000 points of potential failure. A Japanese joinery structure has 0. Then the nail arrived. Not suddenly, gradually. In the 1860s, Japan began its Meiji Restoration, a deliberate westernization of the entire country. Western building methods came with Western ambitions. Balloon framing, dimensional lumber, wire nails by the keg. The appeal was undeniable. A nailed wall goes up in an afternoon. A joinery wall takes weeks. A nail costs a fraction of a cent. A joinery connection costs hours of skilled labor. In an economy that suddenly valued speed and industrial output above all else, the math was simple. Build fast, build cheap, replace when it fails. After World War II, the transformation accelerated everywhere. The American building industry exported its methods across the globe. Dimensional lumber, 2x4s and 2x6s, was designed specifically for nail construction. The wood is kiln-dried too fast, milled to standardized dimensions that optimize for nailing, not for carving precision joints. The species are wrong. The moisture content is wrong. The grain structure is wrong. Modern lumber is manufactured for a 30-second connection, not a 300-year one. Building codes cemented the shift. Every code in the United States and most codes worldwide requires specific fastener schedules. Nail size, nail spacing, nail pattern, all prescribed down to the inch. Try submitting building plans to a county permit office with traditional Japanese joinery connections, specified instead of nails. They will require engineering calculations from a licensed structural engineer, calculations that may cost more than the joinery itself. The codes were not written to accommodate skill. They were written to accommodate speed, and the industries that profit from speed, the lumber mills, the fastener manufacturers, the contractors who bill by the hour and not by the century, made sure the codes stayed that way. The result is a world of 50-year buildings, structures designed to stand just long enough to be financed, just long enough to be sold, and just long enough to need replacing on a schedule that keeps the entire supply chain profitable. The average American home uses over 20,000 nails. Within 15 to 20 years, those nails begin corroding. Moisture travels along the shank into the surrounding wood. The fibers split. The connection loosens. Framing contractors call it nail sickness, and it is built into the timeline. Roofing lasts 15 to 30 years. Siding lasts 20 to 40. The frame itself, if you are lucky, lasts 50 to 70 before the accumulated damage from thousands of corroding fasteners compromises the structure. A home that lasts 500 years is a home that is only sold once. A home that lasts 50 generates demolition contracts, rebuilding contracts, and material sales in perpetuity. Permanence is not a design failure. It is a market failure, and the market corrected for it by eliminating the skill that made permanence possible. Fewer than 100 Maya Daiku master carpenters remain in Japan. An unbroken lineage of knowledge that stretches back over 1,000 years is now held by fewer people than could fill a classroom. The greatest of them was Tsunekazu Nishioka. born in 1908 into a family that had built and repaired temples for generations. Nishioka spent his life restoring Horyuchi and rebuilding Yakushichi Temple using only traditional tools and joinery. No power tools, no modern fasteners. He selected each timber by hand, reading the grain the way a doctor reads a pulse. He once said, "Trees have a second life as timber, and the carpenter's job is to give them that life." Nishioka died in 1995. He had trained apprentices, but the pipeline is thin. When the last master dies without passing the knowledge forward, a joint type that took centuries to develop vanishes in a single afternoon. The Japanese government has designated traditional carpentry as intangible cultural heritage. The word intangible tells you everything. You cannot hold it. You cannot store it. You can only pass it from hand to hand, and the hands are running out. But the earthquakes kept proving them wrong. In 1995, the Great Hanshin earthquake struck Kobe, Japan. Magnitude 6.9. Over 200,000 buildings were damaged or destroyed. Elevated highways collapsed. Modern steel and concrete structures pancaked. But traditional timber frame buildings with joinery connections survived at significantly higher rates. The flexible joints did exactly what they were designed to do 1,000 years earlier. They absorbed the shock, they danced, and they held. In 2011, the Tohoku earthquake struck. Magnitude 9.0, one of the most powerful earthquakes ever recorded. Traditional timber structures again demonstrated superior seismic performance. Buildings that had been standing for centuries rode out a force that crumbled modern construction around them. In 2020, researchers at the University of Tokyo used three-dimensional scanning and stress testing to analyze traditional joints under simulated earthquake loading. Their findings confirmed what the Miyadaiku had known for a millennium. The joints outperform metal fasteners in seismic conditions. They absorb more energy. They redistribute load more efficiently. They fail more gracefully, deforming rather than snapping, giving the structure time and space to survive. Kyoto University continues biomechanics research on joinery. Shake table tests in Japan consistently show the same result. Joinery frames outperform nailed frames every single time, but a few carpenters refuse to forget. In Kobe, the Taganaka Carpentry Tools Museum preserves not just the tools, but the knowledge. Visitors can see joints that were cut 300 years ago and still hold firm. In the United States, a woodworker named Chris Hall has spent years documenting Japanese joinery techniques through his writing on the carpentry way, translating knowledge that was locked in Japanese language text for generations. And technology is closing the gap that killed joinery in the first place. CNC routers, computer-controlled cutting machines, can now carve traditional Japanese joints with machine precision in minutes instead of hours. Companies like Hundiger build industrial timber processes that cut complex joinery at production speed. Researchers at ETH Zurich and MIT are developing robotic fabrication systems that can produce joints the Miyadaiku spent lifetimes mastering. The labor cost argument, the only real argument against joinery, is evaporating. This matters to you. If you're building a timber frame, a cabin, a workshop, homestead structure, joinery is no longer out of reach. CNC files for traditional Japanese joints are available online. A modest CNC router can cut joints that would take a master carpenter hours. The wood costs the same. The hardware costs vanish because there is no hardware. No nail plates, no joist hangers, no hurricane straps, no lag bolts. Just wood, shaped with intention, joined with geometry, built to last not decades, but centuries. The housing crisis is not just about cost, it is about disposability. We build homes designed to be replaced on the same schedule as appliances. 50 years and done. The mortgage outlasts the structure, but a home built with joints that tighten over time, that flex in earthquakes, that contain no metal to corrode and no fastener to fail. That home is an inheritance, not an expense. It is a structure your great-grandchildren will live in. That possibility threatens every industry that profits from planned failure. Horyuchi is still standing. It has been standing for 1400 years. No nails, no bolts, no screws, just wood meeting wood, shaped by hands that understood something we chose to forget. Earthquakes came, and the temple danced. Typhoons came, and the joints held. Centuries passed, and the wood grew tighter, harder, more resolved. Everything we have nailed together since is already cracking, already rusting, already scheduled for demolition. The Miyadaiku knew that a building is not a product. It is a promise that what you raise with skill and patience will stand long after the fast and the cheap have returned to dust. The joints are waiting. The knowledge is open. The wood remembers what the industry forgot. Build it once, build it to dance, and it will stand for centuries after the nailed world has fallen silent. If this archive opens something for you, subscribe to Lost Build Archives and hit the bell. Every like and every share preserves what they tried to erase. The next archive opens soon,